Welcome to lesson 1.4, relationships in patterns. The focus of this lesson is to determine a relation to represent a pattern in a set of numbers. Or in other words, we're going to be learning how to develop algebraic expressions and evaluate them based off of patterns of numbers in tables and different word problems. And I'm looking at page 20 and 21 in the textbook if you want to follow along with me. So my first question is just, what is a relation? And all a relation is a variable compared to an expression that contains the same variable in it. In other words, the variable is just related to the algebraic expression in some way. So what we're going to look at first, in order to help us determine relationships that represent a pattern of numbers, is being able to identify patterns that we see in sets of numbers, whether it be in a table or in a word problem. So I've copied and pasted from our textbook, it's on page 20, a simple chart that shows a relationship and some sort of pattern between a term and a term number. So we have our term numbers of 1, 2, 3, and 4, and then we have the terms of 3, 6, 9, and 12. And so this table could go on forever and ever. It doesn't. It only shows us the first 4 term numbers and the first 4 terms. But what I want you to look at is, how does each term relate to the term number? For all of those numbers, it has to be the same pattern. So do you see some sort of pattern where the term relates to its term number? How do they relate? So in this situation, the term down here is 3 times the term number, right? So 3 is 3 times 1. 6 is 3 times 2. 9 is 3 times 3. 12 is 4 times 3. So the term in this example is 3 times our term number. So if I asked you, what would the term be if the term number was 100? So instead of continuing the table until we get to 100 by going, let's say like 5, so what would our term number be? 12. We know that the term numbers are going up by 3s, so that would be 15, 6 would be 18, and so on and so on. If we were to do that all the way until we got to 100, that would take us a long time. So this is where algebra and developing algebraic expressions comes into play, because we can, knowing the pattern and the relationship between those numbers, we can develop an algebraic expression so we can evaluate any term number, no matter what number it is. So, looking at the relation between the term and the term number, we know that that relationship is 3. We know that the term is 3 times the term number. So 3 times the term number. So if I represent my term number as n, because that's our variable, if I wanted to solve for any term number, I would just replace n, my variable, with that term number, and it would give us the term. So knowing that my term number n is 3 times my term, my algebraic expression then becomes 3n. So 3 times any term number, I can evaluate that and it will give me my term. So going back to my original question, if I wanted to solve for the term number of 100, and I say what term number is 100, instead of continuing my pattern, I just now have to replace my 100 with my n, because I know that n represents our term number. So I could go 3 times 100, because I know that our terms are always 3 times our term numbers, and that would equal 300. So I know that the term for the term number of 100 would be 300. So looking at a second example, if I say I want to know the term or the value, I want to know the term or the value for a term number of, let's say, 273, how would I solve that? Again, I look at my original expression that I developed, 3n, because I know that my term is always 3 times my term number. And we've already established that the n, which is our variable, represents our term number. So I would just have to plot my new number for my term number with my variable. So then I can evaluate this expression, which becomes 3 multiplied by 273, which equals 819. So my term for the number 273 would be 819. So this is where algebraic expressions and algebra really comes into handy, because it lets us solve any problem as long as we can replace our variable with a number. So we're going to look at one more example together in developing a relation, and it's going to be based off of more of a word problem this time. So our question reads, Mr. Prasad plans to hold a party for his group of friends. The cost of renting a room is $35. And I just like to underline the important parts of the question just to help me better organize my thoughts and the information. So the cost of renting a room is $35, and because the question doesn't say otherwise, we can assume that we only need one room, no matter how many of his friends come. Whether one friend comes or whether 20 friends come, we only need the one room. The cost of the food is $4 a person. So that number will change depending on if one person comes or if 20 people come. If one person comes, we know that the cost of food will only be $4. However, if 20 people come, we know that the cost of food, because it's $4 a person, will be $80 a person. So how am I figuring that number out? I'm adding my number of people and I'm just multiplying it by 4, right? So that number changes depending on how many people come. So looking at our first part of our question, write a relation for the cost of the party in dollars for n people. So we don't know how many people are going to come to his party, but we want to write a relation so that no matter how many people show up, that we could evaluate the expression and figure out how much the party would cost. So looking at the numbers we've underlined already, the cost of renting a room is $35. That's our constant term. That does not change no matter how many people come to the party. It will be $35 no matter what. So we take the cost of the room, and then we need to add it to the cost of the food, which is $4 a person. So over here, we've already kind of developed an expression between the cost of the food and the number of people coming, which is n times 4, n multiplied by 4, or 4n, that's the same thing. So 35, we would need to add to the cost of our food, which would be 4 multiplied by the number of people that are coming, which is represented by our variable n. So this then becomes our relation for the cost of the party, and we call it a relation because there's a relationship between the number of people and the cost of the party. So looking at the second part of the question, how much will the party cost for 10 people? So we know that our variable represents the number of people. So all we have to do is take the number of people and replace it with our variable. So it wants to know how much the party will cost for 10 people. So in this case, I would just go 35. That's our constant term. That doesn't change. And then we need to add it to the cost of food, which would be 4 multiplied by 10. And then we evaluate this expression, 35 plus 40. So the party would cost $75 if 10 people came. The second part of the question says how much would it cost if 15 people came? So we do the same thing. We just replace our variable in our relation with 15 because 15 people are coming. So 35, the cost of the room, added to the cost of the food, which would be 4 times 15 in this case, which would be 35 added to 60. So the cost of the party for 15 people would then be $95. And then looking at the last part of our question, how does the relation change if the cost of the food doubles. So what does that mean, doubles? It means, whoops, that means it's 2 times the number. So in our original relation, the food costed $4 a person. If that doubled, that would mean the food now costs $8 a person. So our new relation would then be 35 added to 8n. So the cost of our food has just doubled. And then the question says, how much more would you pay for a party of 10? So our original cost, if the food was $4 for a party of 10, was $75. But now it says if the food doubled to $8, then how much would it cost? So we would just replace our variable with 10 people. So 35 plus 80. So the new cost of our party would be $115. And then it says, what is the difference? How much more would you pay? So then we would have to go 115, which is our new number, subtract 75, which was our old number. 115 subtract 25. So the difference you would pay if the food doubles would be $40. And how do you know that makes sense? We know that that answer makes sense because the cost of food per person is $4 more a person, and if there's 10 people, 4 times 10 is $40, so I know that that answer makes sense. So just to end off, I'm just going to leave you with a practice question to do. So I've just made a quick little chart here, and I would like you to try to see if you can see how each term relates to the term number and develop an expression for that relationship. So thanks for watching, and come to class with any questions you may have. Thanks.